Dear students, today we are going to see the methods of preparation of hydrogen halide, especially hydrochloric acid. Its properties and uses. Only those things we are going to see. Mostly hydrogen chloride or hydrochloric acid. It is prepared by the decomposition of metallic chloride, mostly sodium chloride. When sodium chloride is treated with sulfuric acid, it forms sodium bisulfate and HCl. Sodium bisulfate and HCl. Sodium is replaced by hydrogen, HCl. Here sodium bisulfate. Only one hydrogen of sulfuric acid is replaced by sodium now. Again, the sodium bisulfate can again react with one more molecule of sodium chloride to form sodium sulfate with the liberation Na2SO4 and then HCl. So hydrogen chloride can be formed by the decomposition of chloride. The hydrogen chloride gas which is formed can be dried by passing again concentrated sulfuric acid. Concentrated sulfuric acid is a best dehydrating agent. Therefore, the hydrogen chloride that is formed may have moisture. When it is passed over concentrated sulfuric acid, again, you will be getting dry HCl. It can be liquefied. At lower temperature, it will become its liquid. And its boiling point and melting point are found to be 189 Kelvin, that is boiling point, and the melting point happens to be 159 Kelvin. So it becomes solid still lower temperature. Hydrogen chloride can be obtained in the frozen form at very low temperature. After all, 273 Kelvin is 0 degrees Celsius. Still lower temperature. It will become liquid above 189 Kelvin. And it will be in the frozen form below 159 Kelvin. So hydrochloric acid is a liquid, it is a gas, it can be a solid. Hydrogen chloride can be a gas. It can be dissolved in water to give hydrochloric acid. It can be liquefied. All those things are possible. And when it is dissolved in water, when hydrogen chloride is dissolved in water, it gets ionized. Chloride ion and hydrogen ion. Hydrogen ion with water will become hydronium ion and chloride ion. This is how it is getting ionized. Alright. So hydrochloric acid is a strong acid which ionizes in the form of H plus and Cl minus. H plus exists in the form of hydronium ion. So that is about preparation and important some property. So it is a strong acid. It can be liquefied. It can be dissolved in water. It acts as an acid. These are all the basic things. Then this hydrochloric acid reacts with metals to liberate hydrogen. Whenever hydrochloric acid is made to react with metals like zinc, magnesium, etc., it forms metallic halide, that is chloride. Along with that hydrogen, liberation. You can complete your equation yourself. With carbonates like sodium carbonate, calcium carbonate, magnesium carbonate, like that, CaCO3. It liberates carbon dioxide and water. Hydrochloric acid. Whenever an acid is added into carbonate salts, carbon dioxide gas will be liberated. Sodium halide and water. This is the usual reaction. That also you can write yourself. You can try. And with the bicarbonate, say sodium bicarbonate, instead of sodium carbonate, bicarbonate, NaHCO3. After all, it is a salt from carbonic acid, very weak acid, but dibasic acid. If one hydrogen is replaced by sodium, you will be getting sodium bicarbonate. If both the hydrogen atoms are replaced, you will be getting sodium carbonate. So this is how we get sodium bicarbonate, carbonate. When it is made to react with hydrochloric acid, again, you will be getting sodium halide, carbon dioxide and water. You can try to complete the equation. So with metal halide and hydrogen, with the carbonates, metallic halide, chloride, water and carbon dioxide. And with the sulfite, when it is made to react with sodium sulfite, say Na2SO3. SO4 means sulfite, SO3 sulfite. With the sulfite, it liberates sulfur dioxide. Carbonate, carbon dioxide, sulfate, sulfur dioxide. Same type of reaction. Sodium chloride, sulfur dioxide, water. So, have you completed the equations? Let's try. Zinc, valency 2, therefore resultant Cl2 plus H2 to HCl. Balanced equation. Magnesium also having valency 2, therefore MgCl2 plus H2, hydrogen is liberated to HCl. MgCl2, H2. Here, 2 sodium chloride we need, therefore 2 NaHCl, 2 NaCl. Carbonate get decomposed to carbon dioxide, CO2, oxygen plus 2 hydrogen, water. Carbon dioxide and water. That's all. If you go in for calcium carbonate, you can write calcium valency 2, therefore CaCO3. Sodium valency 1, therefore Na2CO3. That you may be knowing. So you will be getting CaCl2, calcium chloride. CaCl2, CO2 plus H2. H2CO3, carbonic acid. H2O, CO2. CO2, H2O. With sodium bicarbonate, sodium chloride, again H2CO3 we are getting, therefore carbon dioxide and water. I think in the book they have balanced wrongly. 2HCl. 2HCl not needed. NaCl, H2O, CO2. When sodium bicarbonate is treated with hydrochloric acid, we get this product. With sodium sulfate, similar to this. There carbon dioxide, here sulfur dioxide, that's the difference. So you'll be getting 2 NaCl, SO2 plus H2. So with the metals, metal halide hydrogen, with carbonates, carbon dioxide and water, with sulfite, sulfur dioxide and water. Metal halide, sulfur dioxide and water. So these are the common reactions. Apart from that, one important thing, you may be knowing about aqua regia, royal water. Aqua regia. What is aqua regia? Aqua regia, royal water. 3 parts of concentrated hydrochloric acid. Sorry, 3 parts of concentrated hydrochloric acid and 1 part concentrated nitric acid. 3 parts HNO3 plus 1 part concentrated hydrochloric acid, nitric acid. 3 parts concentrated hydrochloric acid, 1 part concentrated nitric acid. This mixture is known as aqua regia. Aqua regia can dissolve noble metals like gold, platinum, etc. This is known as royal water. It can dissolve noble metals like gold, platinum, etc. When gold is made to react with aqua regia, that is chloride ion containing chloride ion, nitrate ion. Let me write like that. It contains chloride ion and nitrate ion. What is the product we are getting? You will be getting chloroauric acid if I write hydrochloric acid and nitric acid, but I have started to write ionic equation. Gold is an element, therefore neutral, 0. Chloride ion, Cl minus, H plus Cl minus, nitrate ion, H plus NO3 minus. When it is allowed to react, you will be getting AuCl4 minus. Because it will become chloroauric acid, HAuCl4 you will be writing. So simply AuCl4 minus. Bracket not needed. We can write AuCl4 minus as such or AuCl4 bracket minus. No problem. AuCl4. Ion. What else you will be getting? The nitrate radical will become nitric oxide, NO. Nitrate radical will become nitric oxide, O. And then what else? We also have H plus ions. H plus ions. Let me write H plus ions also. I can write H plus here itself. Au plus H plus CaCl minus plus NO3. Likewise, let me write. All right. So gold, is allowed to react with hydrochloric acid and nitric acid. We have written ionic equation. Instead of writing HCl and HNO3, it is written like this. So hydrogen get combined with oxygen to become water. AuCl4 minus nitrate radical becomes nitric oxide. Hydrogen get combined with oxygen to become water. Now how to balance the equation? AuCl4 therefore compulsorily 4Cl minus. Alright? Minimum. And then nitrate becomes nitric oxide. At least if one nitrate radical become one nitric oxide, loss of 2 oxygen, at least 2 H2O. At least 2 H2O. Therefore 4H plus. Minimum. Is it balanced equation? Yes, as such it is balanced. 4 plus 4 minus nullified, 1 minus, 1 minus. Okay. So totally 5 negative charges, 4 positive charges. Therefore 1 negative charge, the process. Balanced. A simple balanced equation. An ionic equation we have given. AuCl4 minus. Likewise in platinum, Pt is made to react with this royal water, that is aqua regia. You will be getting chloroplatinic acid, the molecular formula being H2PtO50PtCl6. It goes like this, H2PtCl6. If 2 H plus ions are eliminated, you should get PtCl6 2 minus. So PtCl6 2 minus. Here AuCl4 minus, PtCl6 2 minus. Because gold plus 3 oxidation state, 4 chlorine atoms, minus 4, total charge becomes minus 1. Here platinum plus 4, 6 chloride ions, minus 6, therefore minus 2. Alright. Gold plus 3, plus 1 or plus 3, mainly plus 3. Auric chloride you used to write AuCl3, it forms AuCl3. Platinum common oxidation state 2 and 4. Here platinum with oxidation state 4 plus 4 minus 6, total charge minus 2. Alright. And then let me rub the oxidation states. Plus NO plus 2H2O. Better we are getting 3 molecules of PtCl3. That understanding will make you to give balanced equation easily, little bit easier. 3PtCl6 2 minus. Therefore how many chloride ions? 18 Cl minus. 18 Cl minus. H2O we may not be knowing how many H2O. Suppose now let us try to balance the equation based upon the charges. Here we have 18 C minus. Here we have 6 minus. I am calculating only chloride here and PtCl6 here, 0 minus 1. Together plus 4 minus 2, charge becomes 2 minus. So 18 Cl minus has produced 6 minus. From 18 Cl minus and 3 Pt, we have got total charge minus 6. Here 18 minus, here 6 minus. Loss of how many negative charges? 12 negative charges. Here 18, together 18 minus. This 3 into 2 minus, 6 minus. Therefore difference 12 minus. 12 minus we have to add here. Or there 12 positive charge should be in excess there. Here 12 positive charge should be excess over NO3 minus. Then the equation will be balanced. How? When NO3 becomes NO, when NO3 becomes NO, 2 oxygen atoms are lost. Those 2 oxygen atoms goes to H2O. Therefore, at least 4H plus we have to write. If I write like this, 4H plus and 1 NO3 minus together, 4H plus and NO3 minus together, 3 positive charges are being added here. 4 plus 1 minus 3 positive charge. Likewise, I need 12. That means I have to multiply the whole thing by 3. 4H plus NO3 minus will result in the formation of 1NO and 2H2O. That's what we have seen. 4H plus and NO3 minus together will produce 1NO and 2H2O. Balanced equation. Charges 4 plus 1 minus. Therefore difference 3 plus. Now we have to compensate 12 plus in the reactant side. That means it has to be multiplied by 4. Therefore it is 12. It is 4. Now 12 hydrogen. When 4NO3 becomes 4NO minus, NO, nitric oxide. How many oxygen atoms are lost? 4 into 2, 8. Therefore 8H2. It has to multiply by 4, that's all. 4 times. Balanced equation. So, aqua regia or royal water is a mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid. When aqua regia is made to react with gold, it gives AuCl4 minus, maybe chloroauric acid. Platinum will give chloroplatinic acid, PtCl6 2 minus, ionic equation alone we have given. So that is about important reactions of hydrochloric acid. With metal, liberation of hydrogen. With metallic carbonate, carbon dioxide and water. With sulfite, sulfur dioxide. Again in the older edition they have given sulfate. It is sulfur dioxide only. This equation is not balanced correctly in the book. So those corrections we can make. And with the gold, with the platinum. That's all. Now regarding uses of chlorine. What are the uses? Hydrochloric acid. It is used in the manufacture of chlorine. From hydrochloric acid, oxidation of hydrochloric acid will result in the formation of chlorine. Ammonium chloride and glucose from starch. So we can get chlorine, we can get ammonium chloride, because when ammonia is made to react with hydrochloric acid, we will be getting ammonium chloride. Then we can get glucose from starch, cellulose, etc. Then it is also used in the extraction of glue from bone and bone ash, that is bone black we say, bone black. When bone is burnt with the limited supply of air, we will be getting bone black, bone charcoal. It will contain carbon along with that calcium phosphate and all. So to purify this, hydrochloric acid is used. So these are all the uses of hydrochloric acid. It is used in the manufacture of chlorine, ammonium chloride, glucose from starch and cellulose, and it is also used in the extraction of glue from bone and in the purification of bone black. Bone black is nothing but bone charcoal. Bone charcoal is obtained by the combustion of bone with limited supply of air, and for the purification it is used. So that is about uses of hydrochloric acid. Next, mainly about hydrogen halides we are going to see. That we shall see in the next class. Thank you.